Hello and welcome to yet another South Korean College Scholastic Ability Test video. Today we will solve the following problem. Function fx is differentiable on the set of real numbers and satisfy the following conditions. What is the value of f minus 1? The first condition says 2 times fx squared times the derivative f prime x equals f2x plus 1 squared times the derivative f prime 2x plus 1 for all real numbers x. And the second condition says f minus 1 over 8 equals 1 and f6 equals 2. And f minus 1 gotta be one of these 5 values. Alright, so obviously we have to start from this seemingly complicated condition A. But in fact, it is not complicated at all. If you take a look at the left-hand side, we have fx raised to some power, in this case 2, multiplied by its derivative f prime x. And on the right-hand side, we have the similar expression f2x plus 1 squared multiplied by the derivative f prime 2x plus 1. Now where can we find this kind of expressions where the derivatives are multiplied to the original function? In the chain rule, right? More specifically, the derivative of fx to the power of n, right? If you differentiate fx raised to the power of n, you have n times fx to the power of n minus 1 by the power rule, and by the chain rule, you have to multiply the derivative f prime x. What about the right-hand side with f2x plus 1? Well, it comes from the slightly more complicated case of differentiating fax plus b to the power of n. In this case, you have n times fax plus b to the power of n minus 1, then the derivative f prime ax plus b, then you have to differentiate this ax plus b and multiply it, so we have additional a here. With this knowledge, let us take a look at the given condition again. Since we have powers of 2, it is clear that each side comes from the derivative of a function cubed. If you differentiate fx cubed, you will obtain 3 fx squared f prime x, and if you differentiate f2x plus 1 cubed, then you will obtain 3 f2x plus 1 squared times the derivative f prime 2x plus 1 times the derivative 2, which is 6 times f2x plus 1 squared f prime 2x plus 1. But in the given condition, we have coefficient 2 on the left-hand side and 1 on the right-hand side. Therefore, the left-hand side must be the derivative of 2/3 of fx cubed, and the right-hand side must be the derivative of 1/6 of f2x plus 1 cubed. Therefore, from condition A, if we integrate both sides, we obtain 2/3 of fx cubed on the left-hand side equals 1/6 of f2x plus 1 cubed plus c, where c is the constant of integration. And how is this newly obtained condition going to help us? Well, now is the time to address condition B, where the values of f minus 1 over 8 and f6 are given. Using these values, we can find the value of constant c. But how are we going to do that using these two seemingly unrelated values without knowing the exact expression for fx? The key here is that on one side we have x, and on the other side we have 2x plus 1. And this relation enables us to find the values of fx at different values of x. But in order to do that, let us first rearrange this equation a bit. Say f2x plus 1 cubed on the left-hand side, then we have 4 times fx cubed minus 6c. Now let's see what happens when we substitute x with minus 1 over 8. Then we have 2x plus 1 is 2 times minus 1 over 8 plus 1, so it is 3 over 4. So on the left hand side we have f 3 over 4 cubed equals 4 times f minus 1 over 8 cubed minus 6c. And the value of f minus 1 over 8 is given as 1. So we have 4 times 1 cubed minus 6c, so 4 minus 6c. So we have obtained the value of f3 over 4 cubed, but this value doesn't seem quite useful either. Well, let's keep doing this anyway. Now we substitute x equals 3 over 4, then 2x plus 1 is 5 over 2. So we have f 5 over 2 cubed equals 4 f 3 over 4 cubed minus 6c. So using this value for here, we have 4 times 4 minus 6c minus 6c, which is 16 minus 30c. So now we have obtained the value of f5 over 2 cubed. And guess what happens if we substitute x equals 5 over 2? If we calculate 2x plus 1, we have 2 times 5 over 2 plus 1, which is, holy smoke, we have 6. And the value of f6 is given in the condition. So we have f6 cubed equals 4 times f5 over 2 cubed minus 6c, and f6 is 2, and f5 over 2 cubed is 16 minus 30c. So we have 2 cubed equals 4 times 16 minus 30c minus 6c. So 8 equals 64 minus 126c. So we can find the value of constant c, which is simply 4 over 9. Therefore, back to the integrated relation over here, we have 2/3 of fx cubed equals 1/6 of f2x plus 1 cubed plus 4 over 9. Now the problem wants us to find the value of f minus 1. This can be done by substituting x equals minus 1 into the above relation. Then, fx becomes f minus 1, and f2x plus 1 also becomes f minus 1. So we have this equation, which can be rearranged into 1/2 f minus 1 cubed equals 4 over 9. So f minus 1 cubed equals 8 over 9. Therefore, if we take the cube root, f minus 1 equals, the numerator simply becomes 2, and the denominator is cube root of 9. And since 9 is 3 squared, we can rationalize the denominator by multiplying cube root of 3 at both numerator and denominator. Then we have 2 times cube root of 3 divided by, since this is cube root of 27, which is 3, we simply have 3. Therefore, the correct choice is choice 4. And that was all for today's video. If you enjoyed this video, please go check other videos of my channel, and don't forget to hit that like and subscribe buttons. And as always, I will see you in another video.